Hi everybody, my name is Pietro Fontola and I will present my E90 final project, which is Urban Traffic Data Analytics with AWS. In my town, we have almost 60 traffic monitoring devices. They count the number of vehicles that travel on important city streets. Each device every day sends a file with the collected data to a central storage area. Files have been gathered for several years. We wanted to make sense of this huge amount of data and answer questions like how many vehicles travel on the street, which roads are used most, and similar questions. So I proposed to build the following pipeline with an Amazon S3 bucket, AWS Glue, Amazon Athena, and Amazon QuickSight. Let's have a look at the data. They are in an S3 bucket. As we can see, there is a folder for each sensor, and the folder contains all the files sent by the sensor. We can have a look of the content of one file. This is what the file looks like. It reports the number of vehicles in interval times of 10 minutes. To make all this information available in a structured way, I ran a crawler on the files and it built this table with this metadata. This table can be queried with Athena by simply using SQL, even if there is no relational database under the hood, but only the files. And these are the data. QuickSight is the dashboard building tool. It can read the data from Athena, and I connected it to Athena and built a business intelligence cube with one fact table, this one here, with the number of vehicles, and three dimensions: date dimension, time dimension, and sensor location dimension. This is a preview of the data from the dataset. Once we have the cube dataset, we can build a vast set of representations of the data. This, for example, is a pivot table representing data by year, month, and sensor location. We can filter data by year, by month, and also by location. This is a bar chart showing the number of vehicles by location, and these are the busiest roads. This is a line chart showing the number of vehicles during the day. We can add more sensors and we can choose start and date. Finally, since we know latitude and longitude of each sensor, we can build a map and see where they are located. In conclusion, I would say the technology used has the following advantages. There was no need to build complex ETLs to gather data from files. The crawler did the whole job. The system can scale to gigabytes of data with no need to make any change. The system is fast. Refreshing the dataset from the bucket takes 1 minute to load 200 megabytes. Performing an analysis on a dataset is almost immediate. QuickSight is very user-friendly. Provided you design carefully the cube, building an analysis is an easy process. The only disadvantage I noticed is that it was quite difficult to use the crawler. But apart from that, the whole design was quite easy to do, and the result is good.